Okay, so welcome to week 12 of the NPTEL session on C programming and problem solving through programming in C. This is also happens to be the final session, and this is week 12. And today we will be covering some of the advanced topics related to pointers and structures and things like these. And hopefully you'll find this session useful. At the end of the session, we will be also discussing some of the problems which you might have faced or which you might be having, and make sure you clarify those and in this concluding session. So let's get started. As usual, I'll start by first discussing the multiple choice questions, and then we will move on to a few programming assignments. Okay, so let me start by sharing my screen. So I hope my screen is visible. So let me open up the sessions for today. So this is, I'll start as usual, as I was saying, with the multiple choice questions. And after the multiple choice questions, I'll move on to the few programming assignments. So let's start. Just let me know that uh, before I start, if there are any questions that you might have had before, because since this is the final session, I also want to spend some time addressing some of the questions or doubts which you might be having. So please feel free to ask. You can also put it on the chat over the course of today's session, and I'll occasionally come back and look through the chat as well, or also you can unmute yourself and ask whatever you feel comfortable with. So let's get started. So which of the following themselves is a collection of different data types? So if you think about string, it's a collection of characters. Array is also a collection of things of the same data type. Character is just not a collection, but just as what do you say, atomic data type in C, while struct or structure is the only one which kind of a data type in C, which allows you to have a collection of different variables of different data types. So it's the right answer for this, or the right option for this thing is a structure or struct. Okay, so now let's look at the next question here, where you are asked to predict the output of the program. And you see the first line. The first line basically creates a structure definition, which is struct xyz int a. So it's a structure whose name is xyz, struct xyz, and it has only one element, which is a of type integer, right? So when you create a struct, now the next two lines, obj1 and obj2. So let's first think about the first line, where you have this obj1 and the curly braces, the number 11 is given. So what this means is that a structure is gets created. So the first is the definition of the structure, the first line, and in this line the real structure is getting created. So this is the name of this structure is obj1, right? And it has the a of the belonging to obj1 is set to 11. And next, then you go here, and obj2 equals to obj1. So when you assign you put equals in a structure, it is not done by memory, but it is done by reference. So what's happening in here is that a new structure is getting created called obj2, and that structure is assigned all the elements, that the values of all the elements that are in obj1, so that are being copied. So it is not something where the same memory. So these are two structures which occupies two different memories, and this is something important to know, because later on, if you change any values in obj2, they will not be reflected in obj1 or vice versa, because they are two different structures themselves. It's just that what this equals does is it just copies all the values in the elements of obj1 to all the values in the elements of obj2. So this is a copy and not kind of a memory indirection to the same location in your RAM. So this is not that. Okay, so then with this concept being clear, let's look at what are the print statements are doing, and also the other as well. So here, if you look at this obj2.a, so what this is doing is it's printing the value of a in obj2, and we know that in the previous line, obj2 and obj1 are copied the same values. So the first thing that gets printed is 11, right? So the first you get 11 is getting printed, right? And after 11 gets printed, so let's just keep a note of that. I'll open up a new thing just to keep a note of what's getting printed when. Okay, so okay, so let's take this in the head, and so the 11 is getting printed in the first case, and then we go on and here where we set obj2 is the a member in obj2 to 101, and then we print a member of obj1. So obj1, if you remember, still has the same value of 11. So again, 11 is getting printed, and then we go to obj2, right, and then that's get printed, and obj2 we have changed that value to 101, so we print 101. So you see what's getting printed at the end after all the three print statement is 1 1, then again 1 1, and then 101. So 5 ones, 1 2 3 4 5, and then 0 1. So if you look at this, the right option will be option B, where you have 5 ones and then 0 1. Okay, so you may try to write this in code and also see if that is what you get. But since this is quite straightforward code, and I hope you are fairly advanced, given this is week 12 of this session, you will be able to do this yourself as well. And I will not be walking you through this right away if you do not have any doubt regarding this. If you have doubt, then please feel free to ask. Then I'll just take more time in explaining this by writing the code for this as well. Okay, since there are no doubts, I'll just move on to the next question, which is question 3. As you can see in here, again, this is asking you to predict what's the output of the following code. And here, I think I would take some time in discussing the answer here, because this is kind of a bit more advanced concept regarding use of pointer arithmetic as well as postfix and prefixing plus plus operator. So let's write this code, and then we will discuss what's happening, and then I'll also kind of explain you each of these lines what is going on. Okay, so I have like a sample C code ready. This is the hello world code, which you are already, I hope, familiar with. And just for your reference, I have also used a lot of list of headers, and just for you to look into the future, I would say that these are some of the most commonly used headers in C. So take a note of this, and when you are writing the code, perhaps you will be at some point of your time while writing long codes for your own work, you will be needing various kinds of functions which are belonging to some of these headers, which are already available in the C language. Okay, so with that being said, let's write this code. So the first line is int I, right? And next line is just creates a pointer. So we will create this pointer ptr, and I have also covered the next line is actually what is called dynamic memory allocation. And you see, I have also already covered dynamic memory allocation in one of the extra sessions, which was on Sunday last week. And I hope that you already are familiar with dynamic memory allocation, and because this was also discussed in the lecture series. So what this does is it creates memory and assigns the pointer to the beginning of that memory address, and this memory is reserved in the not in the stack but in the heap. While in case of static memory allocation, the things are mainly assigned in the stack, but these memories are larger size memories, typically speaking, and they are created on the fly when the code is running, so during runtime, and they are created in thus heap. And the idea here is that if there is an error in memory allocation, then this pointer will at the end of this step, if it didn't succeed in allocating the amount of memory that you have asked for, then this pointer will be null. If this is null, then you'll know that the malloc didn't work fine. If this is not null, and you know that null is a special thing in C, so it's all in uppercase, so NULL. So this is kind of the thing. So, and if this is not null, then you'll know that, okay, my memory allocation worked fine. Okay, so now let's see what is done next. So what is done in here is that there is a for loop which goes from I equals 0 to I less than 5, I plus plus, right? So this is the for loop, and what the for loop is doing is it's assigning the values of value I to the pointer. Now this is a completely valid way to do it. PTR I equals to I, right? So this goes every element in the array, but this is the same. When you write this in C, the compiler knows that it has to go to the ith position and then look at what is the value in that position and change that value to I. So if you want to do that explicitly, and these two are equivalent, just like what I have written before and what I am writing now are completely equivalent, and it is up to you to use whatever you wish. But I believe the one which was done before I removed this and written this new statement was more straightforward. But again, it depends on your test of what you want to use, and this is perfectly also fine. And this uses the general pointer arithmetic because your pointer is int, so it knows that whenever you add 1 to it, it has to move by 4 bytes because that's the size of an integer in the memory. Okay, and now we will put in the print statement. So let's do that. So let's see, I'll put in print f, and then let's me put this %d space a comma p star ptr plus plus, right? So this is the first thing that I do, and then here let me do now next one will be something like star ptr plus plus, right? And then the next one will be star ptr, and then next one will be star plus plus ptr and plus plus star ptr. Okay, so let's have it, and just for the sake of it, I'll also have a new line as well, but I mean, it doesn't matter. So let me run this code. As you see, once I run this code, the value which I get is 01223. So here it is 01223 is the right answer, and as you can see, the D is the right answer. But let's think about why we get this output, because that's important, and that is what we will be expected from you to answer during the exam. So let's briefly break down the code and see why do you get this output. Okay, so for that, I'll open up again my notepad where I keep where I will be explaining each and every steps of how this is going on. So let's look at this. So you see that in the first instance, what I am having here is the array values are getting assigned. In fact, instead of notepad, what I think a better way to do it is use the debugger. So that also will help you getting used to how one would debug this code. Okay. So what I'll do here is just put a breakpoint in here. So that kind of tells me where to stop executing the code and pause the execution, and then I'll debug this. Okay, so now I have the debugger open, and you can see the value of I is first a garbage value, so because I has not been used, and PTR is also kind of a garbage value in here to start with. So I am now at line 11. My code is waiting, and now I'll just execute this line, and as soon as I execute this line, you see PTR gets assigned a value, and a size is being assigned to PTR. Okay, so also note that this particular code is not a good code in a sense that it is leaking. So you do not have a free statement after malloc, and it is quite dangerous to have malloc which has no free statement, because it can quickly overflow your memory if you do this multiple times, and your program might crash or give rise to segmentation fault. So it's always advisable to use free with a malloc. Okay, so and because you are responsible for freeing that portion of the memory, and then only that memory can be used by other parts of your code or by some other code itself, or you can overflow the RAM that is present in your system if you do this multiple times, and such a program is called a memory leaking program, which is certainly not a good sign of to have in your code. Okay, so let's start here, and you can see what this is doing is just assigning the value. You see the pointer, you see the PTR plus I, and gets assigned the value of 0, and then the other values are also getting assigned accordingly. So as you see that the value of I is changing from one to the other, and we go to 4. Okay, so now we are at the print statements, right? So this is where the interesting things happen. So let's think about what's happening for star PTR plus plus. So for that, I can put in a watch. So I want to see what's the value of it. So I do a star PTR. So let's first do a PTR. So this gives me the pointer. So this is the memory address. So 0x denotes that it's a hexadecimal number. So you must be aware that memory addresses in computers are written in terms of hexadecimal numbers. So 01778728 is the kind of the memory address where this code lies, and this is kind of the pointer. Okay, and if you want to know what is the value at that pointer, so what you do is you do a star PTR. So this is the value of where your pointer points to, right? and this is kind of 0, as you can see. Okay, and now what you can do is, let's also take a note of here in notepad what is your array. So your array is 0, 1, 2, 3, and 4. So this is kind of the array which we have and which we are starting with, and our PTR to start with points at the location of 0. So when you do a star PTR, what you should get is what you should get is a PTR, the value at star PTR, and that should be that is what is going to get printed, and then PTR should advance by 1. Okay, so the thing that would get printed when you execute this step, as you can see, is 0, right? And why 0 is getting printed, and this is because, as you can see, the first memory location is which would get printed, and since plus plus is postfix, it would be PTR will be increased by 1. So as you can see, initially it was, let me stop this code because I have forgotten what the memory address was, and let's debug this once again and go to that line. Okay, you see the memory address, it is 0738708. So let's take the last 4 digits, 8708, and let me note it down. So 8708 is the last kind of the 4 digits of the memory location where it is pointing to, and the value at that memory location. So star is dereferencing, so it accesses the value at that memory location, and the whatever is that value gets printed, and after that is getting printed, PTR is advanced by 1 in terms of pointer arithmetic. And you know that this is integer, so this must be going by 4 more steps, right? So what you should do is this is in base 16, so you add +4 to it. So okay, so this will be the new memory new value of PTR, and it should point to 1 because this is the next memory location. Okay, so once you do 8708 +4 in kind of in hexadecimal, the arithmetic will be 8708. So let me break it down. I guess you already must be knowing how this is done. So 8 + 4, if you do 8 + 4, what you'll get is 12. And you know that 12 in hexadecimal is C. So the next thing that you will have in here, after you add 4 to it, will be 870C, should be the memory location of the next place where your pointer value, PTR value, should be, and this should point to the location where the next element of this array starts. And so your pointer right now, I will give an arrow to it. So this is where your pointer points to right now, and this is what is getting printed. So if I not go to the execute this line, you will see 0 is getting printed, and after the 0 is getting printed, so this is your array is still this, but your pointer now moves to here. So now your pointer is pointing to the place 1, and therefore it will have a memory address of 870C. Okay, so note the memory address right now here or here, anywhere you look for, and the value at that memory address is 0, so that is what will get printed. And now I go to the next step, and you see that the pointer has now changed to 870C. As you can see, and this exactly corresponds to adding 4 to it, so you have 870C, and the value star PTR, the value there is 1. As you can see, instead of 0, the value is there is 1. Okay, so this is now we are at this line, line number 15. But make sure you understand this, and therefore we see that 0 is getting printed. So now let's see what is happening in here. So now because of this bracket, what's happening is the pointer is getting dereferenced, and then it is being added. So when you do a star PTR, the value at the location which the pointer is currently pointing to is getting used. So what is the value that it is at the location which currently the pointer is pointing to? This is 1. As you can see in here, the pointer is now sits at 1. So what is going to get printed is 1, and then the value there is going to get updated, but the value of pointer is going to remain the same. Here the update is at the value, because we have already dereferencing it and then increasing it by 1. So after dereferencing it, we are increasing it by 1, and also this plus plus is after, so it's postfix. And because it is postfix, first the value, the dereferenced value is used to by printf, and then it is increased by 1, right? So then the dereferenced value, as you can see, will be 1. So what will get printed is 1, and the value at that same location is going to change from 1 to 2. Okay, so now what would happen is your array next will be here 0, and this will be 2, 2, 3, 4, and your pointer pointer is not going to change because first the dereferencing is being done and then it's appended. So the pointer is still will be pointing to the same element, but the element itself is going to change to 2. But before changing to 2, since it's a postfix, the previous value, which is 1, will be passed to printf. So what you are going to see in here getting printed is 1, right? And here, as you can see, the value here is still 870C, which was previously before as well 870C, but the value itself has just got changed to 2. And but then again, what is getting printed is 1 because you see that this was postfix. So now this is very simple, star PTR. So what this is doing is printing the value which is at the location of the pointer, and you know that the value at the location of the pointer is 2 because in the previous step it was updated from 1 to 2. So that is what will get printed. So when I do a star PTR, you see that this is what's happening in here. Okay. So now let's look at the next step. In here, now this is a postfix, and what you are seeing in here, sorry, this is a prefix because the plus plus is before PTR, and this is directly getting applied to the pointer. So now this will, what this will happen is that here the pointer is going to get updated first, and then it will be dereferenced. Okay, so the pointer is going to get updated by one more value. So now it will be going to the next number. So now it is going to the next number. So what will happen in here is that, so this is your new array 0, 2, 2, 3, 4, and now the pointer is going to point to the next in the list. So this is nothing but 2. So now the pointer is going to point to 2, although the value is the same to which the function the pointer is pointing to, but this will correspond to a different memory address. So the value of the pointer will again increase, and increase by how much? Increase by 4 because it is an integer, so it's a size of 4 units. So let's also do the kind of the binary, not binary, but hex addition. So we will, this is, you know that 870C is now the new memory address. So this is the new memory address, and to which we will be again adding 4 to it. So if you add 12 with 4, right, what you will have is 16, right? And since it's hexadecimal, you will have to take care of this 16. So what this will do is adding a 0 to it, because you then subtract 16 from 16 because it is greater than 15, which is the largest value added, largest number of the digit in the hexadecimal. And so you add a 0 to it, and then you carry 1, and this 1 will come in here, and then the rest will be the same. Right. So let's have this. So what this is happening in here, I hope you are comfortable with hexadecimal addition, and this is just using the basic principles of hexadecimal addition, where you have C plus 4, which gives you 16, because 12 plus 4 is 16, and hexadecimal is allows you numbers till 15, the digits till 15. So this automatically lead you to a carry. So you 16 minus 16 is 0, so that this number will be 0, and then you carry 1 to it, and 1 plus 0 is 0, so you have 1. So 8710 will be the new pointer. So let me now execute this, and that point, the value at 8710 is nothing but, if you look at here, let me get rid of this window. If you look at here, 8710 is now pointing to this element, which is the next element 2 in here. So let's see what's happening in here by executing this line, and you can see 8710, fair enough, this changes to 8710. This is exactly what we expect in here, 8710, and the value of pointer is still 2, because you see that the value was still 2 in here. Okay, so and therefore that is getting printed. So 0112. So now this brings us to the last printf statement in here, which is this one, using pointers. And here what's happening is, in the previous case, you see that first the pointer is increased and then it is dereferenced. But now what's happening is the pointer is dereferenced, and then the value at that location is increased by 1. And this is again a prefix, so the increased value is what is passed to printf, and not the value before the increase, because it's a prefix. So what star PTR will now give you is the value at this at the current location, and you know that the value at the current location is 2, and then that will be increased by 1. So the value at the current location is then will be increased by 1, but the value of the pointer will remain the same, because we have dereferenced and increased, unlike previously where it was the pointer was increased and dereferenced. So as soon as you dereference it, the value of the pointer remains the same. So the value of the pointer will remain the same. So it still be 8710, but the value of the at the location of the pointer is going to increase. So from 2 it will going to increase to 3, and since this is a prefix, the after increase it will be passed to printf. So what this will mean is that now your new array is going to go to 0, 2, 3, 3, 4, and your pointer is going to point to the same location. This will be the location of the pointer, and what will get printed is 3. So let's see what's happening in here, and fair enough, as you can see, print is getting 3 is getting printed, and if you look at the value of pointer in here, it's still 8710. So as if you remember, that was the value which we were expecting. So the value of the pointer didn't change. So what you get at the end of is 0, 1, 2, 2, 3. So I hope that this was fairly elaborate enough for you to understand why this is happening. This is, I think, in my personal opinion, is a little bit tricky. So I took a little more time in explaining this, and I hope this is clear. If not, then please feel free to ask a question. Uh-huh. Can you explain the difference between? Okay, okay. What I see what you mean. So you mean this one versus this one? Okay, okay, okay. So what, as I was saying, okay, so what you mean is the last two lines, 17 and 18 in here, in the code, right? Okay, so I will again go through this then clearly. Okay, so you have to remember that the things happen from left to right, and what's happening in here is the pointer is increased and then dereferenced. So first it's increased and then it's dereferenced, while what's happening in here is the pointer is first dereferenced and then it's increased. Then the value at the dereferenced location basically is increased. So what I mean by that is, here say if you have a pointer, as you can see in here, think we were somewhere here, right? So here what we are doing is first increasing the value at the pointer. So from 0 to 2, so from here where the function was, where our pointer was pointing to this member in the array, which is the second member, when you do a plus plus ptr, it goes to the next member, right? So now it goes to this member, and then the value at this member is getting dereferenced. So let me give you one more clear example of this. Say you have an array which is, say, 5, 6, 7, 8, and 9, right? And at some point, your pointer is here, so it's pointing to this number, right? And when you do something like star plus plus ptr, when you do something like this, what this means is that first you have to update your pointer to the new location. So first you have to evaluate this statement and then dereference it. So what this would mean is that you update your pointer to the next location. So you have 5, 6, 7, 8, 9, and then your pointer would move from 7 to 8, right? And then you do a dereference. Dereference means what's the value? So the value here will be 8. So at the end of this star plus plus ptr, you will get 8, because the pointer will be first changed to 8 and then it will be dereferenced. Okay, and then what you will get is 8 in here. And then there is also this variant where you have something like this. What this would mean is that your pointer will be, before you change your pointer to the previous location, you do the statement of dereferencing, which was done before. So I hope this was not, this was already clear from the previous one, but in this case, when you do this plus plus PTR star, your pointer is first updated to the next location, which is 8, and then it's dereferenced. Okay, and now let's take the other example. Let me copy this. And the other example, if I remember, is plus plus star PTR, right? So what this would mean is first dereference this. So when you dereference this, what it would mean is that this is going to give you 7 at the location here, right? And now the plus plus PTR would mean change the value at this location, which is 7, to plus 1 by 1, because this is adding it, and assign it to which is 8, and assigning it to the new value. So what this would mean is that this is going to change your array, and this is going to change it to 5, 6, 8, 8, 9. So your array, this array, and your pointer at the end of this, it will still be at the same location. So it will still be at 8. So at the third position, right? And we'll be pointing to this because you are first dereferencing the pointer, asking it, tell me what is the value here at the location of the pointer. So that is 7. And then you are saying update that value by plus 1. So you're updating 7 by plus 1 to 8, and therefore at the same location where your pointer is, now that is getting changed to 8, while this is the rest is remaining unchanged. So I hope you understand what is going on. Yes, the postfix and prefix tells you do you use the thing after the update or before the update, right? Is what postfix and prefix would mean. That do you do it before update or do you do it after update? For example, if you look at here, let me debug this code once again. This is, I think, a good example. Let's move in here. Okay, so here this is, if the plus plus is if you have a variable and you see the plus plus is after the variable, then you'll know that this is a postfix. So what will happen in postfix is that the first this operation is going to happen, and then before. So what this means is your pointer is going to shift the next location, right? But before your pointer is getting shifted to the next location, you will be using the value before what your pointer was. So imagine that besides this, what we would have had is star PTR, okay? And what star PTR would give you the first element of your array. And the first element of your array is 0. So that is what is going to be passed or used in the code, and then the value is going to get updated. So the idea here in postfix is use and then update, while in prefix will be update and then use. So so here, for example, in this specific case, let's take the same example as this 5, 6, 7, 8, 9. Oops, sorry. 5, 6, 7, 8, 9. And here, as usual, your pointer is pointing in here, say, right? So what this would mean is that you do a star PTR plus plus. So your pointer should increase here and go to the next value. But before the increase, you use. So use and then update. So what the thing that you will be using is star PTR, and star PTR will be 7. So the value that will be passed to print will be 7, which goes to printf, right? And then the pointer is going to change. So the pointer is going to change to 5. Now the pointer is going to change to 5, 6, 7, 8, and 9, right? And now your pointer is going to point to this. Now, in contrast to what the other one would do, that having a plus plus before, so which will be star plus plus PTR, right, is what I have already discussed. You have star plus plus PTR. So what this would mean is that you have to do that operation before. So it's update and then use, and not use and update. So it's update and then use. Then what would this would mean is that you update it to the new location. So plus plus PTR will be carried out before. So that's your pointer goes to 8, and then that is going to be used by printf. So remember that with postfix it's use and then update, while with prefix it's update and then use. So that's kind of the idea. But in both the cases, after you have done the step, it must be updated. And the difference between the first and this print statement is, again, this is, so since you, as you know, everything should be from left to right. So this part is done before, and then I mean, this part is done. If you go by operator precedence, you'll see that PTR++ has a higher precedence than this star. So this part is actually executed first, and then a star is being executed, but just because of the operator precedence. But if you want this part, like the dereferencing, to happen, so your dereferencing to have precede your update, then what you have to do is you have to give this bracket. Because you want the dereferencing to happen. So what this would mean is that you star PTR. Okay, so let's go in here, and star PTR tells you what is the value at that location of the pointer. Okay, so say here, let's take the same example, 5, 6, 7, 8, 9, and your thing is at pointer is at 7, right? And star PTR would then tell you that the value at that location. So the value at this location is 7, right? And then it tells you to update that value. So you update that value 7 plus 1 to 8. But remember that this is postfix. So you have to use and then update. So then the value that you pass to printf is 7, because you update it after. So after you have dereferenced it, the value directly goes to printf. 7 goes to printf because you use and then update. So then 7 goes to printf, and then it gets updated by +1 and becomes 8. So at the end of this step, your thing gets updated. So you 5, 6, 7 changes to 8, because you are increasing it by 1 at the location. So dereferencing and then updating, and 8 and 9. And so now your pointer also again points at the same location. So remember that whenever you are just increasing the pointer value, the position of the pointer changes, but your array remains the same. But when you first dereference it and then use postfix, prefix, or anything else, then you are changing the value of the array itself. So this is the basic difference that's happening. So is this clear? Okay, okay. Yeah, just remember that this is quite a tricky thing, so make sure that you are comfortable with it, and I'm happy to spend more time in it if you need, because this is a concept which needs to be clarified in a good way. Okay, so let's jump straight ahead to the next thing, and let me again put this in here. So I hope this is clear why this is 0, 1, 2, 2, 3. Okay, so now let's jump to this question 4, which asks for, which you see that it takes an array, and then the array is being changed to +2, and you see there is for the printf statements. So what is happening in here, as you can see, there is a print statement. So let me take, again, I'll just use the notepad here, and I hope this is clear. If not, then I can again write this code. But for now, I'll just use the notepad, and I hope this is an example which you do not need the code for this. Okay, so we are at the int main. We are going in main and creating an array in here. So these are the elements of the array, 7, 11, and 19, and then fun is called. So you see that this fun is a function which takes in an array of type integers. So you go in, and here the array arithmetic is done. So remember that in most cases, there can be there are a few exceptions. For example, size of, which I'm not going to discuss. But whenever you just write the name of the array, this is equivalent to writing name of the array is same as writing and ARR 0. So it's called decay of pointers. So whenever the array, you write the name of the array, it automatically decays to and ARR 0. So what this would mean is that what is the memory address of the first element of the array. So whenever you write ARR, it decays to ARR and ARR 0. And this is of the type integers. So what this would do is that it adds 2 to this. So this is same as doing a, so this line ARR equals to ARR2. What's happening in here is and ARR, sorry, ARR 0 plus 2 is what's happening in here. So then what this would mean is that this was your array, right? And ARR was pointing in here, if you remember, because it's the beginning of the array. And now you are assigning this to ARR, right? So this is what's happening in here. And now what this is doing is, so, and as I was saying, this ARR is obviously this. So this is what's happening. So, and ARR 0 is now getting and ARR 0 plus 2. So now what this is happening is that the pointer is now moving to two more places. So it's going to 19. So now 7, 11, 11 and 19. If you do this, you'll see that your pointer is now here, pointing to this element. And now with your pointer, since the pointer is pointing to this element, you when you give a printf and do an ARR 0, right? In here, ARR 0, what's happening in here is you are printing 19, sorry, 19 because your pointer is in here. So the first thing that you're getting that is printed is 19. So the first print statement in here will be 19, and then you move on and come out in here. And as soon as you come out, your ARR gets reset because these were local variables. And as soon as you come out, your ARR gets reset. So again, your whenever you give ARR, your pointer comes back to where it was in the beginning. So your pointer is coming back to 7, as you can see in here. And now if you print 0 and 1, so then that would mean you already have printed 19, and then you print 0, which will be 7, and then 1, which will be 11. So 19, 7, and 11. So 19, 7, 11 is what is going to get printed in here. So is this clear to you? If not, then I'll also can code this up and show this. But if this is clear, then I will proceed. So the main important idea in this was that whenever you come out, whatever adjustments to the addresses that you have done, that always gets reset. And wherever your pointer was pointing, as you come out of the function and go back to the main outside the fun, your pointer gets reset to the beginning of the array. So that is the main concept here that you need to keep in mind, that when you go inside the function, you change the place where your pointer is pointing to in the array, and that function takes in that array. And as soon as you come out, your pointer gets reset and comes back to where it was. Okay. So once this is it's clear, I'll just go on to the next question, where you see that what is the output of the following C code. Assume that the memory address is 2000 in decimal, and integers of 4 bytes are required in the memory. Okay. So you see this is an unsigned integer. So this is a 2D array, as you can see, of unsigned integers, which has 4 rows and 3 columns. And here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are the each of the rows, and these are each of the columns that you see in here. And as you can see, this is x. So this is the start of your thing. And then this goes x plus 3. So x plus 1. So whenever you do x, as I was telling you, that whenever you write the name of a function, it decays to the address. Okay. So let's, but since this is a 2D function, sorry, this is a 2D array, this is kind of a little bit tricky. So let's look at what I mean by this. So this is x, right? And this should decay to and x0, right? So what is and x0? And x0 is nothing but the first row itself. If you remember, this is a 2D, so the first and x0 will correspond to the first row. So this is a special kind of pointer called an array pointer. And this array pointer is going to be of the size of 3 integers because it's the first row. And when you do x plus 1 in here, what this will mean is that this is going to take you to the memory address of and x1, the memory address of the next element. And then if you do an x plus 2, this is going to take you to the memory address of the next element, which is and x2. Because whenever you do the pointer arithmetic and you do an x, it always, except for the size of exception, gives you and x0, so the memory address of x. And x0 is nothing but the first row itself, because to mention and to get every individual element, you have to again give another thing. So for example, if you want to get the location of, say, the element 3, the element 2, then you have to give something like and x0 x1, right? Then that is going to give you the location of element 2, or the element 1 should, that will be and x0 x0. But whenever but since you just have x and you do and that is going to get decomposed to and x0, always gets decayed to x0. So x plus 3 is then going through the same logic. Your x plus 3 is going to go to and x3, right? And what this would mean is that it would correspond to the memory location of first, second. So it's, this is and x0, 1, 2, 3. So this corresponds to this one. So beginning of this memory location. And as you can see, since you are at the location of the fourth kind of the fourth row, you have already gone across 3 rows, right? And since you have already gone across 3 rows, that this would mean that the number of elements that you have gone across is 3 times 3. So you have gone across 9 elements, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 rows, so you have gone across 3 rows, and each row has 3 elements. So you have gone across 9 elements, right? And each element is of the size of 4 bytes, right? So total amount of memory that you have gone across is 36, right? Because you have gone across 3 rows, each rows have 3 elements, and each element is of size 4. So total number of memory that you have stepped is 36. So, and since your x starts with 2000, right, and you move by 36 units, the value that you will have is 2000 plus 36. So 2036 is a value that you are going to have in here. So the first thing, x plus 3 is going to give you 2036. Now let's look at the next thing, star of x plus 3. So you dereference this, right? So what this dereferencing would do, because this is a 2D array, and then what this would mean is that you ask for what is the value at star x plus 3. So what is the value at star x plus 3 is going to give you the beginning of your row. So it's the memory address. So the star x plus 3 is actually pointing to the memory address where your row begins, your fourth row begins, because x plus 3, as you know, corresponds to the fourth row. So where is the memory address where your fourth row begins? The memory address that where your fourth row begins is again the same place. So it's 2036. So that is where your fourth row begins. And now the next one. The next one tells you star of x plus 2. So just like this gives you the memory address where your fourth row begins, star x plus 2 gives you the memory address where your third row begins. All right. So let's see where your third row begins here. What this would mean is that x plus 2. So you have covered 2 rows. Each row has 3 elements, and each element is of size 4. So at the end, what you have is 24 elements. So you are moved by 24 elements in here. So star x plus 2 will then corresponds to the first part. Star x plus 2 will give you the memory address of your of the beginning of your third row, because this is x plus 2, and this is nothing but 2024, right? Because 2000 plus 24 is 2024. So it's 2000 plus 24. This is 2024. And since you are here, now you have to move, you are moving by 3 more elements. So if you're moving by 3 more elements, and these elements, now these 3 elements are along the row. So you are at the third row. So you are at this position 7, 8, 9. So you are at the location of 7, and then you are moving by 3 elements plus 3, right? Because star has already given you a memory address which is of the type integer. So it is an integer pointer, so it moves by 3 elements. So if you move by 3 elements, you again cross 4 bytes of each. So to this, you have 3 elements, and you have 4 bytes of each. So you have 12 bytes more. So you have something like a 2024 plus 12, and this is nothing but 2036 once again, right? So this is also going to give you 2036. So at the end, what you are going to give is these 3 expressions all give you 2036, 2036, 2036, right? But the reasons for having 2036, although the values are the same, the reason for having 2036 in each of these is quite different, as you can see in here. And is this clear to you? If not, then you can please ask your questions. Otherwise, I'll move on.
Sir, star PT returns the content address, sir.
Yes, yes. So star PTR is the content, but since this is like a 2D array, so when you do the first star, it gives you the beginning, it again gives you an address. So unless you give 2 stars, you will not get the content. Okay. So that's kind of the idea in here.
Okay. Okay.
So what you get actually in here is after the first star, you do not get an int star. What you get in after the first star is an array to a like an array pointer. So I think I can write a small code to make this thing clear. Okay, so let me first use the same array that was here in this example, and then I'll use something to make this clear. So what I mean by this is that once you only have 1 star, and if this is a 1D array, you directly get the value. But in case of a 2D array, when you give the 1 star, you just get you still get a memory location, and with only 2 stars that you get the value of any particular element. With 1 star, you just get a memory address which is of the type which is another array pointer. So this is array pointer is kind of something which is different. So let me write this to the array and to make this point clear. Okay. So okay, so let's do 4 and 3. Just for the sake of it, I'll also have something like an unsigned because that's what has been used in here. And this must be equal to this one. So this is the array that we are having. And if you see, say I have something like int star ptr. This is a pointer. And if I do something like give me star x plus 1, right? So what this would mean is that, and then I do something like a print f. I want to know what is the value at that star ptr plus, let's do something like what's the value. So let me print the first print star like a ptr, and this is p. So I'll just want to print that pointer that is here, the value of the pointer. Okay. So and then what I will also print is I do another star. So star ptr is already 1 star, and this is like doing a 2 star to it. So just to be clear, I also do something like star of x plus 1, right? So this line, like line 18 in here, is same as line 19 because there is already 1 star which gone in PTR, and then I am starring PTR, and which is resulting in 2 stars. And this is same as doing line 19 where I'm giving the 2 stars together. Okay, and this pointer is not an integer pointer. So this is actually wrong, although the code will allow it, but it will generate a warning in most cases. So let me run this. And you see that the code is going to run fine. And you are going to get 4 because that beginning is 4 in both the cases. Like if you do, I'm doing a star PTR and star PTR. So you get 4 in both the cases, as you can see in here. And the reason that you get 4 in both the cases is because this is the same operation. You are doing 2 stars in here. And the pointer location is 0b3. So this is kind of the memory location that you have. Okay, but you will get a problem in here. And the problem is that like the code generally will give you a warning. Let me do that in here. So when you do something like a in star ptr x plus 1, and let's do this, and you see what you get is again 4 and 4, the same thing. But here you see that there is a warning. Although the code runs perfectly fine, this gives you a warning in the thing. And the warning is that when you just do an x plus 1, what you have is not a pointer to the same location, but what you have is and pointed to an array. And if you look at carefully at the warning location, it says that initializing int star differs in levels of indirection from unsigned int star this. Okay, so this, although like if you still give unsigned because this was unsigned, you'll still have the warning here. Okay, so let's look at the warning again. So it says that unsigned int star differs from unsigned int star 3. So look at this thing that after the star there is a bracket and then 3. And you see the warning, this warning is happening because the X that you have in here, this is, as I was saying, that whenever you have X, this is same as having and X0. Sorry, this is not a dollar, but and X0. And the type, like what is the type of this pointer? What is the data type of this pointer? The data type of this pointer is something like unsigned int star 3. What this would mean is that this data type is of the size 3. So this actually corresponds to a collection, not just one integer, but collection of 3 integers. So this actually points to the entire row itself, and not just one value. And that's why when I give an int star ptr, this left hand side is different from the right hand side, and that's why I get this warning. So to fix this warning, what you have to do is do something like this and 3. So now this would correspond to an array pointer. So this is now a pointer to an array, and if I again run this code, although the code will run fine, but here you'll see that this warning is gone. So now I have a warning at a different place, but this warning, you see, is gone. And now I have obviously a warning at a different place because of the print statement, but this warning is gone because now it is of the same type. Okay, and now when you do something like a star ptr, what you get is the same address. The value is the same, but you still get an address. So to tell you that, let me just do the 2 print statements to clarify this. This thing, say I do a percentage p ptr and percentage p star ptr. This is going to give you the same kind of value. So let's print this, run this. And as you can see, the value that I get in both the print statement is same. It's 04FDCC. So this points to the same location in the memory, but the type of this array is different. Because one is of the type array pointer, and this kind of is of the size of 3 integers, while the next, when you do a star, it is of the size of 1 integer. Okay, so that's why what's happening in here is, let me print this thing. When you go do something like a star, okay, so let me print this. When you do something like a star ptr plus 1, okay, and let me print this. And if you do something like a ptr plus 1, pointer arithmetic is also going to be different. Okay, so this way is going to do a star ptr just to be safe. We do this. So this is going to first dereference it and then add 1 to it, and then the first one is just doing a ptr plus 1. And as you can see, both ptr and star ptr, even if you have dereferenced it, doesn't correspond to the value but correspond to the memory address. But they are they will increase by different amount because the first one is an collection of 3 integers. So when you do a ptr plus 1, it will move by 3 integers, while the next one is going to move by just 1 integer because of it is of the size of int star. It is of type int star. Okay, so let me print this, and as you can see, this is exactly what this has happened. So let's take the example and see what's happening here. Let me open up this one and do the addition in here. So this is your number to start with, and if you move by just 1 integer, right, what will happen is you add 4 to this, right, because your integer is of 4 bytes, and you know that C is 12, so adding 4 to 12 gives you 16, right? So that now what this will happen is here, then what you have is 0 because it's in hexadecimal, and then you carry 1, and this will be 8, and the next digits will be the same, which is basically this. Just move by 1 integer, what you are going to have is this, because you add just 4 to it. So that's why the last statement where this was star PTR and this is of the size type int star, you moved by one integer. The thing that you have had is 80. If you can see in here from 7C, we move to 80, right? But if you move by 3 integers, then what you need to add is 12 to it, right? So this is again your number, okay? And here you add 12 to it, which is in hex is C, right? And if you add 12 to it, what will happen is you have something like 24, right? And now 16 minus 24 is going to give you 8. So what you will have in here is 8, and you then have carry 1 to it, and then 7 plus 1 is 8. So these are the last two digits, and the next digits will be remaining the same. So now if you add C to it, because you are moving by 3 integers, your pointer arithmetic is going to take you to a memory address which is going by 3 integers. So both star PTR and PTR, all the points to the same memory address are of two different types of arrays or two different types of pointers, and they have a different pointer arithmetic. One takes you element wise because it is of the size type integer, while one takes you row wise from one row to the other row and then to the next row, and so it moves by 3 integers. So that's why its type is different. And now say, for example, let me call this PTR1, and these are all then PTR1 that I have done. And now let me also have something called PTR2 in here. But the difference is this will be of just pointer, right? And then this is going to be of the size of the type this, and this is of the type should be integer star, and this is because I have dereferenced it, okay? And now if I again print this PTR1 and PTR2, you'll see that the same value is getting printed, but obviously if I do a PTR plus 1 and then I do something like a PTR2 plus 1, I will get the same output because they are of the same arithmetic is going on in here. So let me do that. Okay, just a minute. I think there has been some problem, so let me just reopen VS Code. Okay, so now let's start to run this code. And as you can see that I do, sorry, here I'm just showing the pointer itself. Let me just start it once again. And as you can see, both of these are pointing to the same location, PTR1 and PTR2, but they are of two different types. I also do not have any warning statement, so that means I've done the same types. And then when I'm pointing it, the pointer arithmetic is different. So now if I want to see what is the value at that location, right, then what I need to do is I have to do 2 stars in there. Okay, so if I want to know the value at the location where pointer 1 is pointing to, right? So what I need to do is I need to do a printf %d, and I need to do something like star PTR1, and that t is going to give me the location, the value where the pointer 1 is pointing to. Whereas if I want to know where pointer 2 is pointing to, I just do a star PTR, and since the memory address is the same, both of which are going to give me the same value, which is 4, as you can see in here. But since 1 star in a 2D array gives you a pointer, you have to do 2 stars. So I hope this is clear to you, and please just confirm if you understand this, then I'll proceed. Okay, great. Great. So let's then proceed to the next question in here, which was this hello world. And this hello world statement you see is doing a malloc of integer of 10. And now if PTR is null, it is printing hello world. So when is PTR null? I think I already discussed this in a while ago, that whenever you do a malloc, and if the malloc doesn't succeed to allocate the amount of memory that you are asking for, it gives a null as a pointer. and now the check is if PTR equals to null, then you print hello world. So the point thing here is that if the memory could not be allocated to PTR, then only it will print hello world. So the right option is B in here, because PTR will be null when it's unable to allocate the memory. I think this was fairly straightforward. So let's move to the next question in here. The program will allocate dash number of bytes to PTR. Okay, so here you see you start with a PTR like an integer pointer, and then you do a malloc. So what this is going to do is put in allocate a size of the which can allocate 4 integers, because it's 4-star size of int. So 4 integers will be 4 times 4, which is 16. So you have PTR gets allocated 16 bytes, but then you have a realloc. So what realloc will do is allocate a new memory with the new size. So the new memory is of the size of 2 integers. So this is 2 times 4, because each integer is 4 bytes, and you have 2 integers, so that's 8 bytes. So if you look at question 7, the program will allocate 8 bytes in here. So the right answer here is 8, because the first it allocates 16 bytes, because 4 times 4 is 16, but then that gets scrapped off because of the new realloc, and it gets reallocated 8 bytes. The right answer here is 8. Okay. I hope this is clear. If not, just please post it in the chat, or you can unmute yourself, whatever you feel convenient, and I'll be happy to respond. So then let's move on to question number 8, where it's asked to like what is this FP is about. And you know that this is like a standard file opening. And again, I have discussed in depth about reading and writing files in C in the extra NPTEL session, which was done last Sunday. So I hope that you are quite comfortable with that. If not, I'll ask you to please go and check that out. And even if you have still doubt in there, you can ask it in the chat box corresponding to that video, or you can also there is a GitHub link to all the codes that was used in that extra session, which was a bit outside what is typically covered in this course. So you can also put in some comments there in the GitHub repo as well in terms of issues. You can just raise some issues, and I will be happy to answer there as well. So whatever you feel convenient. Okay. So here it's just using the file pointer to read from the file called hello, and you can see the struct is a char pointer that points to the first character of a file. So this actually is a structure pointer, and this points to the first character of the file. So the right answer is option B in here. Okay. So now let's move on to question number 9, and you can see that this will. I think now you will be pretty confident, and you can answer this right away by looking at the second line in this code where p equals to n100. You see that this is a constant literal, and you cannot just have an address of operator on a literal. So you can tell it just right away that this doesn't look right, and this will give you a compilation error because of this line n100. You just cannot get the locate. You can get the pointer to a variable, but not a string literal. Okay. So now let's move on to the last question from the MCQ, which asks to find out the output of the code, where you see that there is a structure that's getting created. Okay, before I move on, are there any questions till now? Let me just pause for a few minutes or so, just to check that everyone is on the same page, and then I can move on. Okay, I guess there are no questions. Then I can just directly come in here to discuss the last MCQ question, which is the asking you to just get the output of the following code. And here you see there is a struct. So I think I will type out this code. This is not too long. Let's first create the structure before creating the int statement. So let's have the struct p. And this is going to have something like an int x and air y, and then end it in here. So as you can see in here, I have created the structure, and then I'm going into the main statement, and I missed the return, I guess. And then let me put this in. So struct p p1 120 169 42 64. Okay, and then struct p star ptr1 is going to give you p1, and then I do an int x is equals to size of p1 by 4, size of p1 by 4, and then if equals to of int, sorry, int plus 2 times size of char, okay, and then return 0, right? So let's run this code for now, and you see what I get is true, is getting printed. So now let's try to find out what's happening, and this includes some quite advanced concept. One is about structure padding, and then this is about how structures are created. So this is, if you go to line number 15, what this does is creates an array of structures. So this is struct P is refers to the structure, and P1 is an array of structures. And how many structures are getting created in here? 3. This is an array of size 3. And why this is an array of size 3 is not so intuitive in this code. So I'll explain that. But before this, let me see if something else can be written in here to make this more clear. But first, let me also I want to discuss, which I have forgotten, is about what is called padding of structures. So as you can see, if you look at here and you ask yourself what is the size of this structure, then you see, look at this int, you say this is of the size 4 bytes, right? And if you look at this, you say this is of the size of 1 byte. So you expect this structure should be of the size of 5 bytes. But what happens under the hood is that this structure is of the size actually of 8 bytes. And this is related to something called padding. So the size of a structure is simply not equals to the size of its individual, kind of the size of its individual, if you wish, elements. And this is because in compiler, it does something called padding to match up all the variables, and this is necessary for the compiler to optimize the usage of memory space well. And what I mean by padding will be, I will try to go to a page where this is discussed, so that in a diagrammatic manner, which will make this clear of what I mean by padding. So let me go there. Okay. So I'm also going to copy this link and share this with you over chat, so that you can also have a look at this whenever you want. But the idea here is that imagine that you have like you have three elements in a structure. So this is int x, double z, and short y. So these are the 3 elements you have. One is of the size 4 bytes. This is of the size 8 bytes, and this is of the size again of 2 bytes, because it's a short int, right? And now the question is, what do you expect for this, the size of this structure to be? And if you just naively add this will be 8 plus 4, 12, and then plus 2, so this is 14 bytes, right? But what you will get at the end is something which will be greater than 14 bytes, because of something called padding, which is done to match the things. So if you look at this, this is Z, right, which was double. So this was 8 bytes, and X was integer, which was 4 bytes. So if you look at the value of Z, just diagrammatically speaking, this is of the double the size of X, because X is 4 bytes and Z is 8 bytes. So this is the value of Z. Okay, and this is then the value of X in with respect to Z, which is of the half the size. And if you look at Y, which was shortened, this was 2 bytes, so this will be half the size of X. So it's 1/4 or 1/4 the size of Z. So this is kind of the thing. So you have X, X, Y, and Z, but the compiler wants to align these three. So if you want to align these three, these will be the red regions which will be occupied by your structure, or the compiler will also put additional kind of memory to this structure, what just to have things properly aligned, which helps the compiler to know where things begin and where things end in a more efficient manner. So the compiler is going to block this memory as well for this structure, and this is going to increase the size of this structure to 24 bytes. Why? Because you see each of these then becomes size of 8 bytes, and you have 3 of these. So 8 times 3 is 24. So you have an entire structure which is of the size of 24 bytes. But if you just look at the individual elements, you would have expected something which is 8 plus 4 plus 2, so 12 bytes. But instead of 12, you get something which is of the double the size, 24 bytes, because of how things are aligned. And this is also going to change depending upon what is the order in which you have defined things in your structure. For example, the same struct, if you order it by ZXY, then it will be of a size differently. Why? As you can see in here, this is the size of Z, right? And then you have a size of X which is half the size of Z, and then if you put in Y, it is half the size of X. So this is again occupying 1/4 of Z, and then these will be the 3 arrays, how it will be, and then there will be an extra thing which is just lagging after ZXY as being assigned, and this is the dangling part in here. And if you then and then this is the padding that you would need. So if you look at this, then you have 2 such kinds of rows, each of 8 bytes. So 8 times 2 is 16. So here the size of your structure is 16, and this was just because your order in which you have defined things as ZXY. So the idea here is that whenever you are creating a structure, it is always advisable to define it in such a way so that your largest sized object or your largest sized variable is at the beginning and your smallest size variable is at the end. So you do in a decreasing order of the size of the variables in your array, and that will lead to a struct which has the same elements but will be consuming the least amount of size in memory. The padding will be the smallest. If you have very large number of quite a lot of padding in your struct, it will just unnecessarily occupy some dummy areas in your memory which you could have used for different other purposes. So it's advisable to create a struct which is decreasing in its declaration of the size of the variables inside it. Similarly, there is another way you can do this, which is ZYX, and this is going to also create of the same size as 16 in here, because you see Z, which is again 8 bytes. Then you create Y, which is something like 2 bytes, because so it's 1/4 of the size of Z, and X, which is half. So the padding is somewhere in between. Okay, and then this is again 16 bytes. So these two were quite efficient in terms of having small amount of padding, but this had a very large amount of padding, as you can see in here, just to match the things. So similarly, in our case, we have, as you can see, kind of here, int X. So this is 4 bytes, and then char Y, this is 1 byte. So if you look at this, arrange it in here. So each of these is like 1 byte. So 1, 2, 3, 4. So this is an integer. So this is going to have 4 bytes. And this corresponds to your array X, not array, but the value X. And then if you go to the next one, this is 1 byte. So this is going to correspond to a character Y. But since you want to align this, you need to have 3 more, right? Which will be your padding. So let me show the padding by minus. And then this is Y, right? So the size of your struct, if you look at it, will be nothing but this is 4 bytes and this is also 4 bytes. So your total size of your struct will be 8 bytes. Although if you just add the characters, like add the individual elements, you would have expected something which is 5 bytes, but it's not the case. So is this concept of padding clear? to everyone? Then I'll proceed to the next, explaining the next part of this question. Okay. Okay. Okay, so now let's look at what's happening in the next part. Although this is, I think this is a code that has been written to confuse uh, you all, but I think it is not advisable to write a code like this. What's happening in here is if you give 1 and 21, these first two elements, so this is an array, as I was saying, array of structures. So when you create this 1 and 21 creates one struct where the first element is 1, while the next element is 21. And then it creates the next struct where the first element is 69, so the x is 69, and the next is y is 42. And then it goes to the next one and creates a new struct where x is 64 here. And since you have nothing, this is just assigned a dummy value of 0. So what this is doing is this is grouping the thing in two, because you have two elements for each struct and creating structs. So at the end of this, if you look at the hint in here, this hint tells you that it is int1 char 21. This is how it's parsed. And then int69 char 42 is the next struct. And the next struct is then int64, and the char is automatically given a value of 0. So let's try to debug this code. And then we are going to know exactly what's happening. So you see we are at this line, so local variables, so we have something like a P1, which is now kind of having nonsense values. And when go in here, you see we are creating an array of structures, and each of these structures, if I make it here, you see 0. This is the first array, which has x1 and y21. And then I have x69 and y42, and then I have x64 and y0. And since this is character, 42 has an ASCII code of star. So 42 in ASCII is star. 21 is like a dummy ASCII thing, which is /x15, which doesn't mean anything. And 0 is a null ASCII character, so /0. This is the termination character of your strings. If you remember the lecture or the session where we discussed strings, this was actually a character with which every string ends in C. Anyways, so if you come in here, and now if you look at this size of P1 by 4, so size of P1, so let's look at what the size of P1 is. For that, I'll use the watch thing, and I'll do this thing size of P1 and P1. And if you remember P1 corresponds to the array, and then if you give the size of P1, what you get is 24. Because as you know, that this created an array of three structures, and each structure is of the size 8. To know what each structure is of the size, we can also give something like a size of P10, because this is like the first element, and this is, you see, is 8. So each of the element is of size 8, and P1 is of size 24. So you have something like you have three such elements in this thing, because it's an array of 3 elements, so the total is 24, right? So size of P1 gives you 24. So 24 by 4 gives you 6, right? So once I run this, you see that now the value of x is just some random value or a garbage value, because it's not been evaluated. And now if I do x, you see the value of x is 6. So x gets assigned the value of 6. And now let's see what this compare does. So what the size of int? Size of int we know is already, size of int is 4, right? So what we have in here is 4 plus 2 times size of char, and size of char is 1 byte. So we have 4 plus 2, 6. So that's why x, which has 6, and this one is also evaluates to 6, because size of int is 4 and size of char is 1. So 4 plus 2 times 1 is 4 plus 2, which gives you 6. So 6 equals 6. So this is true. So because that's why we go in here, we print true, and we come out of this statement. So that's why what you get as the output of this program is true. So I hope this is clear to you. If not, then please ask. Okay, I hope there are no questions in here. Then I'll just quickly proceed to some of the questions, the programming questions in here. The first is which asks you to find the factorial of a given number using pointers. So this is fairly simple. We will just use the pointer. So let's just create some function which I'm going to call. Let me do this. I'm going to call this long. Let's see. I am going to call it void factorial, right? And I'll start with int n and long int star fact, because that's what I will be using, because I'm using pointer. And now what I'm going to do in here is just assigning star fact equals to 1, because that's the value first I'll assign to, and I'll just then loop it over from 1 to n, and till that I'll just keep on multiplying. Star fact is the value at fact, and that has to be multiplied with the value at with I, which starts from 1 and then multiply 2, 3, keep on doing this, right? So here I will then assign a value of int, then I'll just do int long fact, and then I'll just do an enter a number. So I'll take in the number from the user, and then I'll just do a factorial, and then just print the factorial of this number, right? And this is like a simple code in here, and let's just run this then, and let's test it with an example. This is, I think, now that you are in this final session, I think you will be pretty confident in what this is. So let's try the largest one, which is 15 in here. So let me give a 15, and let's see what we get. We get something like 2004. So okay, so I think what I have done in here is, let's start with the smaller one first. Say, let's start with the number 5, and it works fine. So let's try the other one, 10, and let's see if the 10 is working fine or not. 62800. So let's see, 3628800. So this is also working fine. Let's see. It can also be the case that I am not, my compiler is not able to deal with a large number. That's why it can cause some problems. So let me again try 15 and see what I get. So yeah, factorial of 15 that I get is this, which doesn't agree to the value that I see in here. But this might be the case that my compiler is not able to do this. I'm not sure what's happening. So let me also, just to see factorial, let me search and see what would be the factorial of 15, just to see if this is not a typo. So yeah, this is like a very large number, as you can see in here. And the thing that which I am doing in this specific case is unable to kind of deal with that. Okay, so let's see. See, I am passing and fact, and when I'm passing something like 15, it's unable to deal with that kind of a large number, which is because of which this problem is happening. And let me do something like a long int, and so, or something like a unsigned long int. This will allow me to have even larger numbers, and print f is fact. So let me now try 15 once again. No. So yeah, I think it's a problem with the dealing with large numbers in my compiler, for which I am having this issue. But for the other numbers, it's working fine. So I'll just skip over this. Okay, so, and if I come across with some other solutions with which I would be able to explain this, then I'll share that in the GitHub repo. But for now, I'll just move on to the next problem, where you see I have like a list of students where I am asked to just arrange this in the merit wise. So this will using structure, right, and taking for students the ID, name and score, and after I take the ID, name and score, I'll put them according to their score. Like the highest one will be printed first and like that. Okay, so let's create a struct. And I think I have also uh, discussed type def, so for which I'll call this student, right, and this will be ID, then a name, this will be care, and let's have something which is large enough, so 128, and what for the thing, and score. So let's see, this was score. That's it. So I have an ID, name and score, and then I am going to create students here, and for which I have first I do something like int n students. Now I'm going to give enter the number of students, and then depending on the number of students, I'll take in n student, and then I'm going to malloc. So what this is going to do is create an array of whatever number of students that I am expecting. And once I get this, I will take in the name of the student, the ID of the student, and the score of the student. And then what I am going to do is I will take in the students, I'll take in the ID, and now for and now I'll just arrange the students according to their scores, right? So for so I'll do something like int scores is equals to, so this is also going to be the same as malloc thing, and I'm going to do a malloc of int, right? So now this will just arrange the students according to their scores. Right. So now I do something like I take in the scores and I put it in this array. And once I take in the scores of the students and put in the array, I do something like a max scores like this. And now I have to arrange the thing according to scores. So now I also create positions, ranks like this. And this has to be, again, locked, right? And n students and size of int. So now I'm going to give a rank, and now what I'm going to do is I'm going to arrange the student, which student is where according to their rank. So I'm going to n students. Ranks I is equals to like I go from I equals to 0 to n students, and ranks I equals to 1. So first 0 students get 1. So if scores j is greater than scores I, so if the scores of j is greater than scores I, then rank I is plus plus, otherwise this. So I assign ranks for every student. So now what this would do is that the first student is again then assigned some rank, which is rank 1, and then it goes in and it says goes to all the students. So from 0 to j, and if j is less than n students, so it again goes to n students, and then it checks that if the jth score is greater than the ith score, then the student's rank gets decreased. So rank decreasing means it's just plus plus. So now after going this, I know where the ranks are. So now I just print the students. So I 0 I then plus plus I, right? And now I'm going to print the students according to their ranks. So I'm going to do something like a print F. So let's see how things are expected. So first it's expected to print the ID, then name, and then the rank number. Okay, so student ID, then D, and then the name, and then the marks. That's it. And then students. So here ranks are given. So what I am going to do is rank I minus 1, depending upon what the rank is, that particular student's ID is going to give, and then ranks I minus 1. So remember that rank starts from 1, but the ID start from 0, so that's why I have this minus 1, name and the score. Then ranks I minus 1, and then this is just going to go out. Okay, so this is going to be ranks. Right. So this is how I think is going to work. And then now let's free everything. So we free the students, scores, and ranks, all the things which we have mallocked. We are freeing it, and let's run the code. Okay, so there are a few statements where we have some problems. So let's try to figure out. So let's see what has happened in here. Syntax error, undeclared identifier, syntax error. I have also do this. I missed the struct. Right. Okay, so let's try to do this. Okay, so enter the number of students. So now I'm going to enter the number of students. So let's see. This is 4 students. 4. So let me also do this thing so that it's easy for me to follow. And then student ID 1, name is PRATIP, and then it's 900, the score. Student 2, then ASUTOSH 600, and then 3. Okay, student 3. Student 3 is Santosh, is NTOSH 750. 750, right? And ID, I think I have done something wrong in the ID. I would have, okay. Let me do this. Oh, sorry. I think you are right. I was muted, and I don't realize that when I have muted myself. But so thanks for pointing this out. And yeah, so sorry. I think I have muted myself at some point. But are you able to hear me right now, or is it? Okay. So accidentally, I muted myself at some point. I hope that this was not for a long period of time, but for a short while. And this, the code that I was writing in here is clear to you. So just to recap, I just took in the values of the students. I went through their scores, create an array of their scores. Now looking at the array, I arranged their ranks, and then I printed the values according to their ranks. And since ranks start from 1, I printed this as rank I minus 1 because the indexing starts from 0 in C. And that's kind of the idea of what has been done. So is this clear now, what this code does? Then I can move on to the next question. Is this clear? Just to please confirm. And once again, I will, okay. And once again, I will put this to this code in GitHub for you to look up. And then that would be, I think, easy for you. And you are free to open up any issues there if you have any doubts. And I'll be happy to respond to that. That, I think, is the most straightforward way. Otherwise, you can also ask questions. And if you are aware, you are also able to, I hope that and last Sunday when I after I shared the like the GitHub like the codes, I shared the GitHub link to that, and I think you were able to access that same GitHub link. Copy link. If not, I am again sharing the same GitHub link in the chat. You can go here and look up at the GitHub link where these codes are already readily available. And yeah, okay. So let's move on to the next one, where I am asked to, here in the question, it's asked that we have to use colloc to dynamically allocate memory and find the largest element, right? So let's get rid of all of these. And get rid of this as well. And now let's do int n elements, and then printf, enter the number of elements, and we take in the elements, and then I'll create an array which is of the size of float. So let's call this a floating point array, which is of the size of float and float, right? So I take in floating point numbers and I do this, and let's me have a free as well, free ARR. So this is going to free my thing. And here I am going to take in the numbers here. So let's see how it's been asked. So here I put in the numbers and taking the numbers then. Okay, so yeah, obviously memory allocation will fail, and then I am going to just take in the numbers from the users. So enter element. So that's going to put in the enter the element. And now I am going to, so what's the question? Here ask the colloc and ask the largest element. Okay, so since this is colloc, I will use not malloc, but colloc. This is a bit different from malloc. Instead of having a star, it gives n elements and size of each element. And this is going to start from 0 and find out the largest element, okay? So let's just do float. And let's just do smallest. Smallest element is minus FLT max. So this is some number which comes as a part of the library, which is called, let's see, limits. So this, sorry, float.h. So if you have a float.h library, this gives you a variable called FLT max, or a macro called FLT max, which kind of gives you the largest value of an integer. And I call it largest. So I assume that my largest value is the smallest value to start with, so that I then keep on going through the integers and find if it is the largest. In fact, I can also do something like, instead of doing this, I think this is more straightforward. I assume that the first value is the largest value. Okay, and now I go through all the elements, and if I do something like if ARR I, so if the ith element is greater than my largest element, then I know that, okay, this is not the largest, but the ith element is, and then I just do that. Okay, and I also do something called int pos 0, right? And here I also do something like a pos I, so I also know the position. And now I do a printf, the largest element is at position this, and this is the largest element, and this is at this position in the array, and I just print it. Okay, so let me just give this number, so enter the number of elements. So now let's try the example. So let's try 6, and let's try 68.90, 34.79, 35.86, 94.98, 40.06, 88.70. So the largest element is 94.98, as you can see, and this is at position 4, which is an extra thing which I have coded in here, but the code only asks you to do this. So I think we are fine, and this code is working very well. So let's move on to the next one. The next one is write a C program to add two distances in input and given in feet and inches. Okay, so let's then, now this requires you to create a structure, and we take in two distances and then do that. Okay, so let's do that now. Then let's create a type def in here, struct. Let's call it distance, and I will have something like, so this is feet, so I'll have something like float feet, and I'll have something like float inches, right? So now I'll take in two of these, so dist1 and dist2, so I'll call distance d1 and d2, and then I do sum of distances, and now I do something like a printf. For the first distance, I'll just do it, enter feet, d1 dot feet, and then I'll enter inches, d1 dot d1 dot inches. So I'll take in that, and then I will again then take in the next one, second distance, and here the feet, and this I go in here, put this in, right? And then let's do the sum of distances and the sum of inches, and then there is additional thing that if it is greater than 12, so then we will know that the number of inches has gone get greater than 12. So that what I'll do is I will then subtract 12 from inches and add one more feet to this, right? And then now let's have the final printf statement where the sum of distances is this, right? And that's it. Okay, so this and this. Okay, so let's run this code. Okay, and okay, I missed the return, so let's have the return in here, and let's run this. Okay, so let's test this then. Let's test this with the first one, which is 5, 11, and 9, 1. So let's try 5, 11, 9, 1. So it's 15 feet, 0.0 inches. Good. And then let's try the next one once again. So it's 40, 11, 10, 11. So it's 51 feet and 10 inches. So 51 feet and 10 inches. So this works fine. So let's try the last one. This is then 10, 5, 25. So you have 30 feet and 10 inches, 30 feet and 10 inches. So you see that this is working pretty well. And I hope this is clear. This clearly demonstrates the utility of using structs and why you would want to do dynamic memory allocation. We have also covered using structs and kind of dynamically allocating and using an array of structures as well, previously like in the student's case. So I hope that this is quite advanced enough for this course, and also this clears you all these different advanced concepts in a nice manner, and now you are confident enough to kind of explain all the things that were asked in the program, right? I think this is also similar, like two 1D integer arrays, A and B of the same size, and store the result in a C array. And this was already covered, I guess. So I leave it up to you to do this, like take two arrays, A and B of the same size. You take this using dynamic memory allocation, and you save it in a new array of C, which is of the same size as A and B, and then print it out. So I leave it up to you. This was also something which was already discussed before many times. So this is, I think, will be straightforward to you. So I leave it up to you. And I am confident enough that now you are at a position that you will be able to do this with ease. So on that note, I am going to stop here and wait for you to ask any questions that you might be having. This might be related to specifically what we have discussed today, or something which we have discussed in previous sessions as well. This is the last and final session, so please clarify your doubts right now. You can either unmute yourself and ask, or you can ask it in the chat, whatever is convenient to you. Yes, file operations and related questions. I think we have discussed file operations in that extra session in more detail on Sunday. And if you still have doubt regarding file operations and things related to that, I would ask you to please ask your specific doubts either by emailing me or opening up issues in the GitHub repo that I have shared, and I will be happy to answer those. Yes, exactly. So please send your queries through issues in GitHub, and I will be promptly answering to those. And on that note, if any of you do not have any more questions, then I thank you all. I thank you for being with me for the entire 12 weeks of this course, and thank you for your time and attention. And I hope that you have learned enough to get started with C, and you are confident enough now, right now, to write any kind of problems that you might be trying to solve in your own kind of research or whatever you are doing. And this is kind of gives you a framework for, or a baseline thing from where you can build up your skills. And I hope all the best for your future endeavors. And thank you all for all the 12 weeks. As I told you, I am grateful that you have spent your time to listen to my sessions and clarify your doubts. And thank you. It has been a wonderful experience. And on that note, I am going to end the session. Have a nice weekend. And thanks a lot. So bye for now. Bye, everyone.